Good morning, grade 12s. In today's lesson, we'll focus on a new concept called the fundamental counting principle. But before we start, let us recap what we spoke about yesterday. So in yesterday's lesson, we recapped some of the probability concepts that you've learned in grade 10 and 11. And what I want you to focus on is the definition of probability and also the complement. Now, we are not going to use the definition of probability and the complement immediately, but just keep it in the back of your head that as we are working on the fundamental counting principle, that we would need to introduce this concept as well. But let's start with a fun, easy example. Our first example reads as follows. At a school's fundraising event, each person who wishes to buy a meal may choose only one food item from each of the following three tables. So on table 1, we have a hamburger, a veggie burger, and a steak roll. So for table 1, we have 3 options in total. On table 2, you have salad, baked potato, chips, or rice. So on table 2, we have 4 options. And on the third table, you can either choose ice cream or a fruit salad. So on your third table, we have 2 possible options. I want the class to figure this out. How many total meals can I make? So let's say the first customer goes to the first table and then chooses an item, and then to the second table, and then to the third table. How many total meal combinations can we make? I'm going to give you a few minutes to discuss it and figure it out. So you guys were absolutely correct. What we need to do is we consider all of the options on the 3 tables, and we multiply it together to get to a total of 24 different options. Well done. Let's look at our second example. This is example 3 in our textbook. It says, in how many ways can you predict the results of a soccer team in 5 successive matches if the results are win, lose, or a draw? So let me help you a little bit here. Here we have 5 different matches. In match 1, you can either win, lose, or draw. And in match 2, 3, 4, and 5, you have the same amount of options. So you can either win, lose, or draw, win, lose, or draw. So this is not like our previous example where we could choose and count. The outcomes now is unpredictable. We don't know whether we're going to win, lose, or draw. So for every single match, we have 3 possible outcomes. Now, if I have 3 outcomes and I have 5 matches in total, can you see it will be 3 for match 1, 3 for match 2, and so forth up until the 5th match. So we'll have 3 options, times 3 options, times 3 options, times 3 options, and we multiply that again with 3 options. So in total, 3 to the power of 5. And if you want to simplify that, that's 243 different outcomes that we can have for 5 successive soccer matches. Now let's pause there for a moment and compare example 1 with example 2. So in our first example, we had 3 tables with different number of items on it, and we simply multiplied all the options together to get to our total of 24 options. In the second example, we did the same, but the amount of options per match repeated. So every match had 3 examples or 3 total outcomes. So it's 3 times 3 times 3 times 3. So it was the same as the first example. Now in our next example, we're moving on to a concept called factorial. What factorial is that options are getting less and less. So let us say you have 5 colored pencils on your table. And we want to see in how many different ways you can organize those 5 pencils. So if I take the first pencil, there's still 4 pencils left. So can you see the amount of pencils are becoming less and less and less. Each time I pick up a pencil, it will become less and less and less. But in the first 2 examples, the amount of options remained the same. So this is a concept called factorial, where your amount of options become less. So quickly grab your calculator. I want to show you something on it. So for factorials, we use X exclamation mark, where the exclamation mark means multiplication. And look what happens. If I say 5 factorial, remember the example of 5 pencils, it will be 5 times 4 times 3 times 2 times 1. So every time I select a pencil, the amount of pencils left on the table becomes less and less, or less by 1 each and every time. And that's called factorial. Now, imagine you have 1,000 pencils. You're not going to say 1,000 times 999 times 998 all the way down to 1. You're going to use your calculator to work out factorial. So on your calculator, let's say we press 5 to work out 5 factorial. Then you press the shift button, so shift. And can you see the x to the power of -1? There's an x exclamation mark there. So that is factorial. So you press that. So it's 5, shift, and then factorial. And you press equal. And you can see the answer is 120. So 5 times 4 times 3 times 2 times 1 is 120. Now let's use that in our final example for today. So let's move on to our third example. It's example 5 in our textbook. There are 6 bedrooms available in a hotel for 6 friends: Adam, Brian, Carl, David, Ethan, and Fred. Each person will have their own room. In how many ways can these people be placed in the 6 different bedrooms? So let's start with Adam over here. Adam has first choice. And what I want you to see is that Adam has 6 possible rooms that he can choose from. Now it doesn't matter which room he chooses. So let's say he chooses room 3. But what I want you to notice is that Adam had 6 options in total. Now let's move on to Brian. Brian can no longer choose room 3 because that's already Adam's room. So Brian has 1, 2, 3, 4, 5 rooms he can choose from. So let's say Brian chooses room 6. But Brian had 5 options in total. Next we have Carl, and can you see the amount of rooms for Carl now is 4 rooms. So Carl has 4, and we continue to do that for the other friends as well. So David can only choose between 3 rooms because 3 other rooms have already been occupied by Adam, Brian, and Carl. So David only has 3 rooms to choose from. Next we have Ethan. So can you see Ethan can only choose between room 4 and 5. And then lastly we have Fred. So Fred can't really choose. He only has 1 option. So Fred would be in room 5. So Ethan had 2 options and Fred had 1 option. So altogether, what we can see is that we can multiply again. So we have 6 options times 5 times 4 times 3 times 2 times 1, which is the same as saying 6 factorial. And if you use your calculator, that is 720. What that means is the total number of combinations in which we can place these 6 friends in 6 different rooms is 720 different combinations. And that is our first lesson on the fundamental counting principle. please go online and complete the worksheet posted. And as always, guys, I'm here in class. I'm going to move around between your desks. If you get stuck, just raise your hand and I'm happy to help you.